now let's do the last graph, which is the cotangent graph. Now the cotangent graph, it's a little bit easier to work with. I think probably the hardest one is probably the tangent graph, just because it doesn't start at 0. And the cosecant and secant graphs start at 0, so does the sine and the cosines. So having that works well with the phase shift. And the cotangent graph actually is really nice too. So one of the things to kind of look at is kind of the same thing, right? But instead we're going to have cosine of x over sine of x. And now we're going to have asymptotes wherever sine of x is equal to 0, which is why you can see the 0, the pi, and so on and so forth. So to graph one particular period, it's nice because you start back at 0, which is really, really nice. Then you're going to go still pi over 4 units, pi over 2, 3 pi over 4, and then we end at pi. So you have asymptotes. It's very similar to the tangent graph. And you have 1 and -1. Everything is built into quarters, but now it's decreasing in this sense. So the graph goes upward, hugging this asymptote, and then goes downward, hugging this other asymptote. So this would be one period of the cotangent graph. So this is what it would kind of look like. So if I were to say the tangent graph is probably the one that's probably the worst in terms of graphing. Here again, the stretching factor, absolute value of A, period. Again, we're back to the pi over B, so we don't have the 2 pi anymore. So you can see that the tangent and cotangent have a period of pi. The domain for the cotangent graph is all real numbers except when x is not equal to pi k, so every pi units you'll have an asymptote. The range is -infinity to +infinity. Equation of asymptotes is x equals pi k, and cotangent is an odd function. All right, so let's just go ahead and jump to the case. It's actually not that bad to graph this guy because now everything's back at 0. When something starts at 0, it's super nice to work with the phase shift and in the period change. So same thing as before. Something to pay attention is the key feature. So there's an asymptote at x equals there's a mistake here. There should be an asymptote at x equals 0. Okay, so at x equals 0, there's an asymptote. There's a point at pi over 4, 1. Point at pi over 2, 0. Point at 3 pi over 4, -1. And asymptote at x equals pi. Okay, so everything will be the same as graphing sine and cosine, except that the pi over b will be just the only thing that's a period change. Okay, so let's take a look at this problem. So let's go ahead and take the cotangent curve. We see that we have a period change and also a phase shift. So I'm going to take out the pi over 2. You got the x, and since I'm taking out a pi, I'm going to have plus 1/2. Oh no. Plus 2. That's what it will be. Okay. All right, so now let's go ahead and take a look at the period. So the period now, the new period, is going to be pi over b, which in this case is pi over 2, which is basically 2. Okay. So that means it's going to complete one full period from 0 all the way to 2. So my start asymptote is going to be at 0 because we're back at 0. And my ending is going to be at 2. Okay, based on what I have here. All right. And now what I'm going to do is I'm going to go ahead and look at the phase shift. So phase shift is just going to be 2 units. Notice that it's a positive, so it's going to be subtracting 2. Subtract 2. So that's what I'm going to do. I'm going to subtract 2 from these two guys. So now it's going to start at -2 and it's going to end at 0. So I'm going to start at -2 and I'm going to end at 0. So here's my asymptotes. let's go ahead and figure out what my halfway points are. This shouldn't be too bad. Halfway between -2 and 0 is -1. Halfway between -2 and -1 is -3/2. Okay, and halfway between -1 and 0 is just -1/2. And let's just graph the cotangent curve, okay? Because there's no amplitude, nothing else. It's just at -1. Oh, that's wrong. +1 and then 1. And it's just decreasing. So this would be 1 period of this particular graph. Okay, and that's just basically it for this one. Okay, so just be very careful. Most of them are pretty easy when they start with 0, and the more that you do that, the more you'll get good at them. For an exam, obviously these take quite a bit of time, so you won't have too many of these.